BTech student Mr. Chaitya Daga, he has done and received, both two students have done their project work. So, and they have written one paper also with respect to this work. So I hope they have give their best performance with the explanation of the coding. Just to showcase your slide once, and after that you go for quick, go through slides, and after that you go for code.
Present here. My name is Chaitya Daga, and this is my teammate Rishi Khandelwal. We are representing Energy University. So we had the privilege of working under the mentorship of Dr. Santosh Sarpati for our project, which is titled Automated Sleep Scoring System with Multi-Fusion Features using ML Techniques. So, sir has given you the basic information about sleep study, about sleep stages and everything. So, we just came through that. The motivation was to enhance the accuracy and the efficiency of sleep states classification by applying advanced machine learning techniques like random forest, boosting classifier, etc., to provide more reliable sleep analysis. These are the papers that we have referenced for our studies. So the data set that we have used is from the we have used from the PhysioNet. It is an open source data set which is available on Google. These are the different waves of different parts of the EEG waves, as explained by sir. So the methodology that we have used in our ML study is, first of all, the sleep data collection. We have downloaded the data set. Then we do the EEG signal pre-processing, which is the cleaning, filtering of the data set. Then we do the feature extraction. For this particular project, we have focused on the frequency features and the Hajot parameters. Hajot parameters include three different categories. We have the Hajot activity, we have Hajot mobility, and complexity. So the Hajot activity, it measures the variance of the signal, which is proportional to the power. This is the formula. We have Hajot mobility, it quantifies the frequency characteristics. And finally, complexity. So this is the basic algorithm. We have the data loading, it's pretty straightforward. Then we have the feature extraction, as I mentioned, all the features. Then we prepare the data, we flatten it, we have the standard scaling features, and we split it into training and testing. That is usually how ML studies are done. We did the split of 70 to 30, 70 is for training and 30 is for testing. Then we train it on our models. We made three models. We have the random forest model, the voting classifier, and the stacking classifier. And these are the different parameters on which we have based our study. We have accuracy, FN score, kappa score, precision, and recall. As you can see, we have reached the accuracies of 85% for five state sleep classification, which includes wake, N1, N2, N3, N4, and REM sleep. These are the confusion matrices. So we have for random forest, for each model, we have done ones with Hajot activity, ones with Hajot complexity, ones with Hajot mobility, and finally we have used all the features, all the Hajot features. So this is for the ROC curves, as you know. Questions? This is for the voting classifier. Next, the ROC curves. This is for the stacking classifier. This is the comparison of accuracy for we received the best results in Hajot activity and almost mirrored result in when we use all the features. So we can conclude that stacking classifier received nearly 86% accuracy, demonstrating its strength for automated sleep staging without manual scoring. And with its rich features and ensemble methods like voting and random forest also proved effective by balancing model strengths and avoiding overfitting. Yeah, these are the references. I'll just do a small demo of the code that we have done.
So this is actually presentation, and based upon that, see, actually in the cases of brain component test, the code is important. Dataset preparation is important. Here Hardik is there one PhD student also work related to sleep under the guidance of So important is what, how you can data to be acquisitions, because the challenging is what we are not get real data because so many ethical concerns are also there. So what about the public data set, challenging data sets with us? So Pigeon is one of the public repository where a lot of data set is related to sleep and available, and those data set IESRU sleep data set one resource, dreams data set, and sleep EDF expanded this data set. So different public available data set we are using here to showcase either our model is correct in comparison to sleep expert or not. Sometimes sleep expert decision is not going to be correct in between the N1 and REM stage, because if deep sleep anyone can justify. For example, your behavior sleep symptom, sorry, your fever symptom is quite confusion. For example, COVID symptom is also some there, viral fever symptom is also same, let's assume. So in that cases, you have to take some extra test to decide either it is COVID or not. The model should be correctly analysis with help of multi-fusions, multi-model or multi-fusion feature combination we have to consider to identify more accurately. So
this is the demo of the code first. So first of all, this is the loading of the data and preparing of data sets. We call them epochs.
So you can tell the data was according to divided epochs.
We have divided into epochs and they contain different mappings. We have also EOG, EMG, but EOG, EMG refer to electro-oculography and EMG refers to electromyography, which is the eye movement and the muscle movement. But we deal with EEG, which is the brain waves. Okay. So we are only taking the EEG signals and then we map them to the different stages. This is wake, N1, N2, N3, N4, REM, and the movement time. We load and create our data sets and we get our features. We have done scaling and filtering of the data set, and now I'm defining the features that I'm going to use: edge of activity, HA, HC, HM, and we have also.
Here we have considered frequency domain features. Frequency domain features, edge of activity, edge of mobility, and edge of complexity. And independently, we have to test the edge of activity, edge of mobility, and edge of complexity. And after that, once again we can combine edge of activity, edge of mobility, and edge of complexity, and analyze impact of analysis. So that's called as a multi-fusion. See, single fusion is what? If you test edge of activity independent, edge of mobility independent, edge of complexity independent. These are the signal behavior analysis. For example, I am already given one example to justify, to identify either the student is good or bad. We have to ranking 15, 16 features. Similarly, here also to analyze the signal behavior in terms of time, in terms of frequency, in terms of time frequency. We have to analysis, and then only we can know either the sleep is going to be disturbed where deep sleep is disturbed, or either light sleep is more, deep sleep is less. If light sleep is more and deep sleep is less, then it is also deteriorating health condition. So you have maintain of your good sleep means maintain of light sleep plus deep sleep. हर दिन आप डीप स्लीप 8 घंटा होगा वो भी ठीक नहीं है, लाइट स्लीप 8 घंटा होगा वो भी ठीक नहीं है. So we have to be maintain a sleep quality with respect to light sleep, deep sleep, and REM sleep. So in these cases we have to consider health activity, health mobility, and health complexity, 3 features independently. After that we have to combine it with all these features and test it.
Then we extract these features in each epoch that we have defined.
See, here we have to divide the data set. Here the data set, entire data set, we have to divide into two. One X is feature set, Y is level. After that, we have to extract the feature from the data set, and then after we have to go for it. No. Yes, one. So here we have to fit with the classification model with the library. and these are the hyperparameters, and we have to divide into two segment X train and Y train, and after that we have to go for test the model, unseen data set, means unknown data set, we have to go for it, give the model, and the model is either correctly predict or not. After that,
after we train the model, we test it on the unseen dataset, as Sir has said, and then we create the confusion matrix and the different parameters to score the how efficiently the model is working. So as you can see, this is how we create the confusion matrix. It is a 5x5 matrix according to all
class
the.
classification. This is so that it is a 5 to 5 matrix where N1, N2, N3 are in. So this is a multi-class classification problem.
So as you can see, this is a diagonal heavy matrix, which means these are the correct classifications. Like these are the true labels, which is vague, and the predicted label, which is vague. So this is the correct classification. All these classifications are actually misclassifications. So if a confusion matrix is diagonal heavy, it means the model is working well. This is the ROC curve. We aspire to get the area under curve as near to 1 as possible, which means the models are performing well. So we have done the same with that was for Hedgehog activity. Now we'll repeat for Hedgehog mobility and Hedgehog complexity, and then for all the features together. We have repeated the same process for each iteration and each model.
So similar way we have to perform more classification techniques for Hedgehog activity, mobility and complexity. And so which results are more effective? Either multifusion or individual? Is there any graph?
Yes, we concluded that using stacking classifier with Hedgehog activity produced the best results for 5-class classification, resulted to 86% accuracy.
The comparative there?
Yes, it was in the PPT actually.
So just use the showcase in PPT so that with results we have got best results. So this is the comparative in between different independent feature with the combination of features.
So this is the final comparison of all the models across all the iterations that we have performed, and as you can see, Hedgehog activity with stacking classifier performs the best. So that was it from our side. Thank you so much.
Thank you so much, both Chaitya and Rishi, for your showcase code. So if anyone have to start research work, so Hardik is here also, sleep related. Already Manish Sharma sir is also very good hands. So we are learning from Manish sir itself only. So I hope all of you have enjoyed the session, because we want proper sleep psychology. So as an adult, we need to 6.5 to 8 hours sleep and to maintain proper mental rest and mental wellness. So I thank to Rahul Chavan sir for inviting us to showcase our small research work. So thank you Rahul sir to organizing such type of workshop, national workshop for innovation healthcare infrastructure using AI and sensor technology. Thank you sir. Any question? You have say one two question you can. Or if not also you have my number is there with Rahul sir, so you can contact my number.
Good evening, sir. I'm Prithviraj, second year CSC student from IITRAM. Actually, I have a few doubts regarding the code. So, will it be possible to show the code again so that we can discuss on the code? Sure. So I would first like to know that the data set which you use so that we can also implement if we like it.
So dataset is available in PhysioNet. You can click on PhysioNet so that there is a different datasets you are getting. SC dataset, ST dataset, Kestel and telemeter, sleep cassette and sleep telemeter. and they are recorded from different South Africa countries, different countries patients are there, and different patients medical history also there. So two files are there. One file is EDF file, one file is annotation file. So EDF file you have to make a pre-processing, and after that you have to load it. And annotation file will be another file. Where annotation file is, we have shown like weight N1, N2, N3. Either somewhere numbering is there for weight 0, N1 1, N2 2, N3 3, RM 4. Somewhere is what directly is the hypnogram is there. So we have to hypnogram analysis at last as per our model. Next.
Also, sir, you mentioned that you will be incorporating some new classification models as well.
We have not focused upon new classification model. All our existing classification model we have do it. Our thinking is multi-fusion combination of features. Hedgehog activity, hedgehog mobility, hedgehog complexity independently we have tested, and we have also taken combined. So what combine? See, for example, I am taking antibiotic. See, one if you go for NAM code, so you have not go for relief after 3 days. But you what you have to take to count medicines of NAM code is not an impact on me. So you can just change the medicine. What he has done? He has done one antibiotic. So antibiotic is what combination of medicines features. Similarly, here also we have taken combination of features, activity, mobility, complexity, and tested either it is more impact to analysis or not.
Also, can you show the classification matrix?
Oh, so I think also the active.
There in